Hey guys, I'm William with Team Accelerate, and today I'm going to be talking to you about CAD, and we're going to do a little bit of introduction to CAD. So, what is CAD? Well, CAD stands for Computer Aided Design. And it's used to design products or components with the aid of computerized software in order to handle the large calculations. So we use computers to handle the rendering of a product and the designing of a product before it's produced. So some of the commonly used softwares are Fusion 360, which is what we'll be talking about mostly today. Um, and it's used almost anywhere. You can run it on most computers. It's a little less powerful than some other softwares. There's a 3-year education license available through most schools, and it's the software that our team uses. Next up is Onshape. It's a multi-person platform. It's really not that powerful. It's simple to learn, it's browser-based, and it's free. So those are the benefits. Uh, Another commonly used is Inventor, which is similar to Fusion 360. It's a little less personalized, and it's an older design of software. It is not cloud-based, so none of your information is stored cloud-based. It's all local. And then, again, you get a 3-year education license. Next up is SolidWorks. SolidWorks is a bit more powerful than Fusion, but it's more complicated and harder to learn. There are more complex geometries that you can attain, and there is an education license, but it's not available to all schools. So why do we use CAD? Well, so we use CAD because it makes designing simpler. You can pull parts directly from most suppliers, and that'll be in the form of a step file. It's easier to manufacture parts because you can then use CNC machining or 3D printing, which will be talked about in a different video. It's easier to collaborate on projects, and you can see if a part will fit on the robot before fabrication. More reasons that we use CAD is because it saves time, it saves money, and there's less of a headache, and then at least with Fusion you can work outside meetings. So organization, I'll show you a little more about organization once we hop into Fusion, but folders are great. No one wants to be sifting through hundreds of files trying to find something. Use important names in order to know what's in a folder, and have a common naming scheme. So, another thing with CAD, with Fusion, all version history is saved, all edit history is saved, which makes it easy to go back and edit, and it's simple to print out images and renderings with material looks. So here is some CAD on our last season's robot. So when you go from CAD into physical objects, try not to deviate from the original design, 3D printing or CNC complex parts when possible. If it doesn't work, go back to the CAD, see what happened, and fix it. Make sure that your tolerances are correct. That's something we'll talk about when we go into CAD. And any changes to the physical should be mirrored in the CAD. And that helps with consistency and make adding features easier, since they'll fit with the current design. The way CAD translates to the robot is system integration and pre-knowledge of what gets done. It also helps with 3D printing and CNC machining.
Some artists have decades to tell their story.
Since some integration is done during the design process rather than afterwards, you don't want to be trying to smash all your systems together when they don't fit with each other. And you don't have to worry about whether your components will fit with each other if you integrate in design rather than afterwards. And then we'll talk about 3D printing later in another video. Why we use CNCing, it's very precise. It's generally pretty fast unless you're doing something with a lot of small holes. It produces a very clean final product. You can make it out of metal. There's no layers, so it's very structurally sound, and it's easily reproducible. So now we're going to hop over into Fusion 360, and I'm going to take you through designing a simple part. We'll look at some organization. As you can see on the left, this is my personal account, so I've got some organization done. And what we're going to be creating today is this simple widget. So I've got all the dimensions required to make this simple object. And so we shall start. So this is what you find. Well, this won't be exactly what you see when you open up Fusion for the first time, but process is always the same. You'll come up and create a sketch. We will choose the back plane, which is this red and green. You can see, we'll select that plane. We'll grab ourselves a rectangle that is 38.1 millimeters tall by 50.8 millimeters. Let's see if I can remember those. So 50.8 by 31.1. Did I remember those correctly? Not quite. 38.1. And so now we have right where this circle will have that midpoint, and we'll be able to make this bottom section pretty easily. So what we're gonna do is we're gonna go ahead and grab our circle tool, and we'll find the midpoint. This triangle, the green triangle that you find, means that's the midpoint. And so this circle is 25.4 millimeters. 4 millimeters, 25.4, which is 1 inch for imperial reasons. And then in order to create this top half, you see it's also got a radius of 25.4, but it's much larger. Well, so the circle has a diameter of 25.4, which is what this symbol means. And then this circle has a radius of 25.4. And so what that means is from this center point out to here is 25.4 millimeters, or 1 inch. So in order to create that, we're gonna grab an arc tool, a 3-point arc, or center point arc would also work. But we'll grab a 3-point arc so that I can show you how to dimension it. And then we'll find this corner, and we'll just put that there. And now you can see it's blue, which means it's not fully dimensioned. So what we'll take is we'll grab our dimension tool, which we'll just place it there, 25.4, and now we've got that arc. And now this looks very similar to this. Now we don't have these markings here, these are called center marks, and we don't have the same positioning on our radius and diameter. See, our diameter is inside the circle, but that's alright. Next, we're going to create this little protrusion, and so that protrusion is 31.75, but it is 12.7 tall. I'm actually going to move this dimension out a little bit so it's easier to see. So it's 12.7 millimeters tall. So what we'll do is we'll grab a line, go from one side to the other, grab our dimension tool, and dimension it from that top piece, or from its line to the bottom line. And what this will do when we put in 12.7 millimeters and press enter, we know this space is now 12.7 millimeters from the top, or from the bottom technically. And then that is all we will need for this first sketch. So what we'll do is we'll press the green check mark, the finish sketch button, and we now see the sketch right here. So if we look up here, we can see that circle isn't extruded, so it's just a hole, and this bottom part is extruded farther, so we know we're gonna have to do it in multiple extrusions. So what we'll do is we know the length of this bottom extrusion is 31.75. So we'll extrude it first. 31.75. And now we have that bottom part extruded. And now we know that from the front of the bottom part to the back of the, or to the front of the upright is 19.05. So 19.05 minus 31.75 is 11.7. Yes. So we'll extrude just these two sections right here. 11.7. Ooh, I get my math right. And now we don't need that sketch. So we'll come up here to this Sketches tab, expand it, and hide that sketch. And now we don't have that mess behind us. And so now, you can see we've got the main shape down. Except there's a little bit of work we need to do on the front here. Now in order to make this hole, there's two things we can do. We can either make a sketch on this top plane, right here, which over here would be this, or we can make a cut from the front plane, make a sketch on it, and then cut it there, which I'll go ahead and show you both ways, just so that you see how it is. But we'll start the way that I would do it, which is create a sketch on this plane, find our dimensions. So we're going to grab our 2-point rectangle, just go ahead and, this top one is 25.4, and then we'll grab our green X, which means we're on top of a line. So this box is now locked onto this line and this line, which is the top and bottom of our piece. Now you can see we have blue on the sides, but black lines on top. So these black lines are fully dimensioned and the blue ones aren't, meaning this rectangle can go either side. So we're going to grab our dimensions, and I'm just going to go to the right. So we'll go from the right side to the right side, and I don't remember my dimension. 12.7. So 12.7 millimeters. And now we have full black lines. So we'll finish the sketch, and we'll go in. So that cut is 6.35 millimeters. So we'll grab our Extrude tool. Now I know that Extrude isn't what you think as a cut, but if we go negative 6.5, right? 6.35, sorry. And so here's a good example. So I didn't put the right dimension in. This is a bigger cut than I needed. So down here on the timeline, I can find that extrusion and double click it, there we go, and it'll allow me to edit. So now I know my dimension is actually negative 6.35. And so now that is the correct length. And now you might be wondering, how do we get these angles? So there's a tool called the Fillet Tool, and what it allows us to do is to click on these two corners, put in 6.35 millimeters, and now there's that angle, or there's that curve. And so that is the full widget. So I'll save that, and since I've already named it, it's giving me a user saved. But if you're saving it for the first time, you'll see a screen. You'll see a screen that says, "Where do you want to save it, and what do you want it to be called?" Roughly. And so I showed you one way, and instead of going back and deleting all my work to show you the second way, I'm just gonna take this scroll bar at the bottom of the timeline, or at the very end of the timeline, and move it back to before we did that. And I'll show you the second way that you could have done this. So what we're going to do is take a 2-point rectangle, and we're going to make it the exact same size as our top plane. Now you could use what's called the projection tool, where you just click on it. The hotkey for projection tool is P, by the way. That's what I use to pull it up. And then you get, instead of black lines, you get purple lines. But either way works. Neither one's correct, right or wrong. I just prefer the black lines over the purple. So I'm going to Control Z that and get rid of those purple lines, or pinkish purple lines. And now we're going to take our 2-point rectangle, make it 6.35 by 25.4. And so now we already have the right size cut to depth. So we have the right width and depth of cut. We just need to cut it down to the bottom of through the entire piece. And again, we have the black line, or the blue lines, so we need to dimension it. What is it? 12 point something? 12.7. So I was actually pretty close with my original placement of that. 12.7. Yeah, you see it didn't move that much. And then, instead of using the fillet tool on the model itself, we can come up here and fillet the sketch. Click these two corners, 6.35, 6.35, and now everything turns blue because we lost our dimension to the edge. but that's alright. Your lines don't have to be black in order to use them. Now, we might not be able to grab that part of the sketch in order to extrude it. So what we're going to do is we're going to take a line from there to there, and a line from there to there, and now we've got these in the sketch dimensioned. Well, kind of. But now those are in the sketch so that we can grab these as part of the sketch. So we're going to finish the sketch, grab our Extrude tool, grab these 3 areas that we want to cut out, and we can pull it down so that it's cutting, and then come up here to our Extrude tool box, and there's a number of different settings you can use, but we're going to come to extend type, there's distance, to object, and all. We want all, and as you can see, it went perfectly to the end of the model. And then we'll press OK, come up here and hide that sketch, and same after product, whether I did this method or the method I showed before. The method I showed before is what I would use, but I've seen people do it both ways. So we'll save this, and then this drawing, it's a way that I can get all the dimensions I need to recreate this model. As you saw, I just used the dimensions from this to create the model, and both this model, or both the widget, this step file to create this, will be in the description, as well as this drawing. And both of these will be in the description. This will be as a PDF, the widget will be as a step file. But so this is a little hint, a few tips and tricks for CAD, and yeah, I will thank you guys for watching, and I hope you guys have a great season. Adios.